Hello, I am back. Um, by the way, my steak was very yummy. It was slightly overcooked, but it was still very good. So, back to part C. So, we are trying to find when the line is the longest or when there's a maximum amount of people waiting in line. So, you should know that maximums occur at critical points and endpoints. So, we are going to find the critical points of the number of people in line. Sorry for those dots that aren't erasing. You see them right there and there. For some reason, they don't want to leave. Okay, so let's see. Our interval is from 0 to 8. So we have to check the endpoints, 0 and 8, and the critical points. But what are the critical points? It's when the derivative equals 0. So basically, we want to know when r of t at 800 of both sides is 800. And we look on the graph, and we can clearly see that happens right there. Bing, 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 bing. The winner is 3 hours. So we can say this occurs at t equals 3. So that is our critical point. So we need to find out the amount of people at the beginning of the day, the amount of people at 3, and the amount of people at the end of the day, and see which one is the largest. And I'm actually going to show you another way to do this. There's actually probably a little bit easier. But 0, we remember that there were 700 people at the beginning. So I will put 700 at the beginning. A of 3 is a start amount, the amount at the beginning, plus the number of people that entered the line from 0 to 3. And so if you integrate the rate at which people enter, that will give us the amount of people that entered, and subtract from 0 to 3 the rate. If we integrate the rate at which people left the line, it'll tell me how many people have left the line. All right, we know the start amount 700. The integral from 0 to 3, we found that on part A. That was 3,200 people. So 2 ways to find this integral. The official way, you find the antiderivative of 800, and that would be 800t. Then you plug in 3, then you plug in 0, and you would get 800 times 3 minus 0. And that is our answer to be 1,500 people. Then A of 8 is going to be a little more work. We still have the A of 0. Now we have to integrate from 0 to 8. Okay, back to this integral. Instead of finding the antiderivative, we actually don't even need to do that. So let me give you a little visual of what's going on. If I were to graph, make this 800, if I graph the function, it is a constant function. The rate of people leaving is constantly 800. So if we want to integrate that from 0 to 3, basically what we're doing here is we want the net area from here to here. Clearly that's a rectangle. The height is 800, the width is 3, 800 times 3. So we could go directly to that without even doing this integral. You could have just put 800 times 3 because They're leaving 800 people per hour. So in 3 hours, it's just 800 times 3. So that would be much easier. All right, so looking at this part, 700 is a starting amount. Now to integrate from 0 to 8, we have to do this. We already know that this part has an area of 3,200. So we need to find the area of the remaining regions. And I guess we'll do this. This one has a width, this part here, it goes from 3 to 6. So the width is 3 and the height is 400. So 3 times 400, that's 1,200 people there. And this is a triangle. The area of that is 1/2. The base is 2 hours. The height is 400. So that comes out to be 400. And this triangle here, area is 1/2. The base is 1 hour. And the height goes from 400 to 800. So that's going to be 400. That'll be 200. Now all those calculations should be done not on the picture because they don't grade the picture. It should be done down below, but for our time reasons, I'll just leave it up there and not take the time to transfer below. But 3,200 plus 1,200, that's going to give us 44 plus 400 more, 48. That's going to be 5,000. So this integral will be 5,000. And this is going to be 800 times 8. You could think of it as a rectangle with a height of 800 and a width of 8. Or you can do the antiderivative and do all that work. And I made a boo-boo. This is actually supposed to be dt, not t. So let's get this answer up. And we're going to find something out here, I think. This is 6,400. This actually comes out negative. 5,700 minus 6,400. You can't have a negative number of people in line, but basically what this means is there's no one in line. Because once you get to 0, no one's leaving anymore, obviously. So you wouldn't continue subtracting. So in essence, this is 0 even though it's not. Let's read the question. It says, while there is a line, people move on to the right at the rate of 800. So when the line is 0, no one's going to be leaving, clearly. And so that's kind of what's happening. It's kind of a weird situation. But I need to do a final statement. What did the question ask for? At what time is the line for the ride the longest? And how many people are in line? So I would say at time t equals 3, at time t equals 3, the line is the longest with 1,500 people. All right, so that is that. Let me show you another way that. Try to erase all this stuff. I think you'll find this way a little easier. And I will show you the concept. We have a theorem. I will explain the theorem after I work this problem out. So we realize there's only one critical point at 3. And what we're going to do now is do a sign chart for that. So we're going to put a number left of 3 and right of 3. And that's my time. And I want to find if the derivative changes signs. So if we look at 2, to find the derivative, I need r of 2. R of 2, R of 2 is 1200, as you can see here. So if you do 1200 minus 800, that's clearly positive. And then we need r of 4. At 4, r is 400. So if you plug in 400 minus 800, that would get you negative. So we see 3 is a relative max. So the theorem goes, if there's only one critical point, and if it's a relative max, then it's actually an absolute max also. And similarly, if this 3 were a relative min, that would be the minimum point. So that assumes you only have one critical point. And I'll show you logically what this means. So to the left of 3, it starts at 0, it ends at 8. From 0 to 3, the derivative of a is always positive, so a is always increasing in this region. From 3 to 8, the derivative is always negative, so the function is always decreasing in that region. Therefore, clearly at 3, a has a maximum. So we could actually write that out. We can say there is a maximum at t equals 3 because t equals 3 is the only critical point and a prime of t changes from positive to negative at t equals 3. Now, I might be really happy with that answer, but if you look, they also want to know how many people are in the line at that time. So the work I did previously for a of 3, you'd have to add and tell the grader that that's how many people are in line. So that is part C. Let's do part D. Let me erase. Oh, I'm going to undo that. Let me erase all this. It's almost all gone. There's those couple of dots, they don't want to go. And I'll delete that. So part D, do not solve, that's important, an equation and one integral expression that gives the earliest time t at which there's no longer a line in the ride. So to not have a line in the ride would mean that the number of people waiting is 0, or a of t would be 0. So I take my a of t equation, which I have, and make it equal to 0. And it looks like we're finished, but we're actually not, because I did not follow instructions. It says, and I can only have one integral expression. Now, I can't do anything about this r of x, but I can with this. If I find the antiderivative, plug in t and plug in 0, I'm going to get 800t. And again, the logic, this is a function with a constant height of 800, and we go from 0 to t, that's the width. Basically, we have a rectangle with a height of 800 and a width of t, so that is our answer right there. So we're done. That is part D. Thank you, and I will now work on the next question.